Question number 56. The compound which will not decolorize bromine water is. We have different compounds given here, and we should know that bromine water will be decolorized by unsaturated compounds. If you look at the given compounds, we'll see that there is the compound that's given in option 4 is ethane, and ethane is an alkane, that's a saturated compound, while all other compounds which are given here are unsaturated compounds. That's why only this will not decolorize bromine water, and that's why this is our correct answer also. After that, question number 57, I have here total number of sp hybridized atoms present in the given compound is. We have this compound given here, and we need to just find out the total number of sp hybridized carbon from this. Here this is Cn. It can be represented in this way. Nitrile it is. Now, in this case, this is sp2 hybridized. This carbon is also sp2 hybridized. This is sp hybridized. Further, it's also sp hybridized. And if I talk about this carbon, this is also sp hybridized. What about nitrogen? This nitrogen is also sp hybridized. It means there are total 4 atoms are there which are sp hybridized, and option 3 becomes the correct answer for this question. Now, after this, next question. Question number 58. Which among the following is not an aromatic species? We have different options in which certain species are given. We have to just choose that species which is not aromatic in nature. What are the conditions for aromaticity? For aromaticity, molecule should be planar. It should have 4n plus 2 pi electron, which should be delocalized, and conjugation should be there. Generally, we consider these are those properties which decides aromaticity in a particular species. If we talk about the first option, sulfur is present there, and it has a lone pair that is participated in conjugation, and due to which it is aromatic in nature. Further, if I talk about the second compound, this is follow 4n plus 2 pi electron, and those electrons are there in conjugation. That's why it is also aromatic. In third compound, we have this anion, and if you count 4n plus 2 pi electron, then definitely you will find that it contains 4n plus 2 pi electrons which are there in conjugation. That's why it is also aromatic in nature. While in fourth compound, if you check 4n plus 2 pi electrons in delocalization, that's not so in this case. And if it is so, then definitely it will not show aromaticity, and this is our correct answer also. After this, there's another compound. Question number 59. The compound having E configuration is. What is this E configuration? In case of EZ configuration, E configuration is that where the groups of more priority are at opposite sides. Now you just have to check here the priority of the groups to identify that whether this is Z configuration or E configuration. Now if you look at the option 3, you will see that halogens are present here in this alkene, and if I just want to know the priority order, bromine has more priority as compared to fluorine. Further, in these two cases, chlorine and bromine has more priority as compared to chlorine also. And you can clearly see that the groups with more priority are at opposites to each other. And that is why it is showing the E configuration. And that's why I'll choose this as the correct option. While if you check other options, you will not find that. Now, let's take question number 60. The major product of the given reaction is. What's the reaction that's taking place here? This is alkene, and HCl is added to it. This is an addition reaction. You have to just find out the major product of this reaction. Let's check what is happening here. We have CH3, CH, CH3, CH, CH2. This is the alkene. On this alkene, you are just adding an acid. What will happen here? In this case, first the addition of H plus ion would be there, and that will result in the formation of a carbocation, that is formed here. This is secondary carbocation. This is not stable. It means in this case there is the hydride shift. This is 1,2 hydride shift here. And that shift results in the formation of the tertiary carbocation. Now, on this tertiary carbocation, there would be the attack of the nucleophile, and it will attack over here to form the final product. That's the major product basically. This is the major product. And where this is given, if you check the given options, you will identify that this is given here in option 2. And on the basis of this, we'll choose option 2 as the correct answer. Now, after this, there's another question.